Starting with question 7, there's going to be more than one method possible to be used in factoring. So we're going to factor completely and state the method used. So first off, I look at this here and I see an a cubed with a minus and 8. I can see a 50 and 8 and I realize, hey, those are cubes. But notice I can't cube 50 and get an exact answer. And I can't cube that little a, but I can find something common. And you know what I notice? There is a 2 that will go in these. So it's greatest common factor is the first thing I need to do. So I have Muhammad Ali here because I am the greatest. And I can factor a 2a out of each of these. So if I factor 2a out, I'm left with a 25a squared minus 4. And in the past, we would be done right here on test. But as I look at this here, I go, wait a minute. There's 2 terms with a minus, and they're both what I call square rootable. So that means they would be a difference of squares could also be used here. Because the square root of 25 is 5. Oh, that should be a 5a. I forgot to edit that. That should be a 5. That should be a 4. And then, so I'm going to have a 2a times a 5a plus 2 and a 5a minus 2. And forget that little, there should be a 5. So now I have factored this one. Oh, this one's got 4 terms. Is there anything common? Why, yes, there is. There's a 2 that's common. There's no variable number in front. So I'm going to divide all these by 2. And after I divide them all by 2, I can see this here. I have 4 terms that I can factor by grouping. So I'm going to draw my line like I do right there. Only deal with this half right here. Now ignore this 2 also. And what will go into 3x cubed and x squared is just an x squared. Now I think this is the hardest one to see. If I take an x squared out of this here, I end up with a 3x. But x squared divided by x squared is a 1. That's a big trick. Notice it made a 1. And so if I have it, and notice I have this 2 still out here in front with this x squared. That's why there's big brackets here. And see this 3x plus 1? If I have 3x plus 1 here, I need a 3x plus 1 here. And what would I multiply by 3x to get a negative 12x? A negative 4. So I would have this here, and then this negative 4 would then factor in right here. Oh, wait a minute. I still have a difference of squares. Because see, that's still a square rootable number, which x's and 2's. So this is what it actually boils down to. 2 times the quantity 3x plus 1 times x plus 2 times quantity x minus 2. Whoa! This one actually had 3 things. A greatest common factor, a factor by grouping, and a difference of squares. So this one, oh, I can see that there's a greatest common factor of a 2x. Oh, even I missed the x there for a second. I can take a 2x out of each of these. So I'm going to have a 2x in front for an answer. And 2x divided by 2x cubed will make an x squared. Negative 2 will go to negative 12 6 times. I take 1x away. And 2x's will cancel, makes it a plus 8. Now, y'all, I do need to check. There's no number in front of the x squared, but I can factor 8. In fact, there's an 8 or 8 and 1, 4, 2. It's a plus sign, which adds to make 6, which is the middle number. So I will have it. So I still have my 2x in front. And x, I skip a space with the 6. And x, I skipped a space with the 2. The larger number always matches the middle sign. So this should be a 4 right here. This should be a 4. All right. So my answer, that should be a 4. Let me go back. I'll try. This is a 4 here. It is not quite factored right. It is a 4. Thank you. I don't know if I can draw on there or not. I cannot.